Okay, let's finish up this lesson that we didn't quite get through in class. We left off with our general definitions of trig functions, which were that sine of theta, any angle, whether it's obtuse or acute or otherwise, is y over r. Cosine of theta is an x value over r, and the tangent of theta is y over x. So we're going to use these instead of opposite over hypotenuse and adjacent over hypotenuse and that good stuff, because now we have angles that are more than acute angles. So something that you might be asked to do would be evaluate the sine of like a 330-degree angle. So we'll start in degrees because I know you're more familiar with degrees and radians, but we will be doing radians soon enough. Get that out of the way. So I'm going to want to put my 330 degrees on the correct quadrant on my coordinate plane. So if you imagine that 0 is over here, when you go around 330 degrees, you've gotten to about here, right? Not quite a full circle. So the right triangle we're going to want to use is this one. And I know that 330 degrees would mean that there's 30 degrees left over to go the full circle. So that right triangle that I have is a 30, 60, 90 triangle. And I just need to label my sides correctly so that I can do all the trig functions. So across from the 30, we're going to have a 1. Note that this has to be negative because we're in quadrant 4 and it's a y value. So y values that are below 0 are going to be negative. Across from the 60-degree angle, we'll have the root 3. This is positive because it's on the right side of the x-axis. And the hypotenuse is always positive in 30, 60, 90 is going to be 2. And now I can evaluate the sine of 330 degrees by using that triangle that I just drew. So the sine of the theta prime is going to be opposite over hypotenuse, or y over r. So negative 1 over 2, or negative a half. All right, so there's the sine of 330 degrees. We're going to have to do a few more of those. Let's do one that's in radians this time. Let me recreate my coordinate plane and do another example. I'll do one in radians, maybe the tangent. Let's do the tangent of 4 pi over 3. Okay, so 4 pi over 3 is a radian angle. If you think about pi as 180 degrees, you can do 4 multiplied by 180 and divide it by 3. I like to think of this as just a little bit past 3 pi over 3. And I know that 3 pi over 3 would be 180. So I'm pi over 3 past 180. If this is 180, and pi over 3 is like 60, so I'm going to go 60 degrees past there. Then here's my angle. That's 4 pi over 3. The right triangle that I want to draw goes to the x-axis. Okay, with this angle in here being 60 degrees. How do I know that's 60 degrees? Because 180 was, halfway around the circle. And then I had to go a further 60 degrees to get to 4 pi over 3, which is like 240 degrees. So between 180 and 240 is 60 degrees. So I know there's my 60-degree angle. Opposite that, I'm going to label the root 3. I have to note that it's negative because my y values are negative in this quadrant. Across from the 30 is going to be my 1. It's positive, so I can... No, it's not positive. Sorry, it's negative. It's on the left side of 0. So we have a negative x value and a negative y value in this quadrant. And the hypotenuse of this triangle is 2. And now I can go evaluate my tangent. Tangent is going to be opposite over adjacent, or y value over x value, which here is negative root 3 over negative 1. And that simplifies to just positive root 3. So that's the tangent of 4 pi over 3. Okay, so you're going to have to do a section of those. And then, although we've been using it, we haven't really practiced just doing reference angles. So let's look at just reference angles. The reference angle is that acute angle that we're using in order to figure out the sine, cosine, and tangent of the obtuse angles and the reflex angles, the ones that are over 90 degrees. So the reference angle is an acute angle between the terminal side of the given angle and the x-axis. If you're just finding reference angles, it might be helpful to picture it on the coordinate plane. So you'll probably see on my answer key that I'm going to sketch a little coordinate plane for these, like for part A. It's asking me the reference angle for this theta, 5 pi over 3. So 5 pi over 3 would be like just short of a full circle, because a full circle would be 6 pi over 3. So we're just 60 degrees short of a full circle, which brings me to here. How do I know we're 60 degrees short of a full circle? Because we're pi over 3 short of a full circle, and I know that pi over 3 is 60 degrees. So if this was your reference triangle that you wanted to use, then the theta prime, the reference angle that you'd be using, is 60 degrees. If the original question is given to you in radians, you should give theta prime in radians also. So when theta is 5 pi over 3, theta prime is pi over 3. Okay? If it's given to you in degrees, like negative 130 degrees, remember negative angles, we haven't done those in a few days, negative angles leave and go clockwise instead of going counterclockwise. So 130 degrees would be past 90, but not quite to 180 yet. So we've got this about there, right? The reference angle is going to always go straight to the x-axis, just like it says up at the top of this screen, between the terminal side and the x-axis. So if that's 130 degrees, then in this case, there's only 50 degrees left over to get you up to the x-axis. So the reference angle, when theta is negative 130 degrees, the reference angle is going to be 50 degrees. We don't need to make our reference angles negative. The reference angle can be positive. Okay. I think that's it for that practice of reference angles. Just maybe sketch each picture so you can see how far you have to go to get to the x-axis, and that'll be your reference angle, and just give the answer as a positive angle. Okay. Then quadrantal angles. So sometimes I'm going to ask you to do sine, cosine, and tangent of an angle that doesn't fall in the first, second, third, or fourth quadrant. It falls right on one of the axes, like right on the x-axis or right on the y-axis. So the definition here is that a quadrantal angle is one that lies directly on an axis. For example, a 90-degree angle is a quadrantal angle. It's not in quadrant 1. It's right on the axis. So a 90-degree angle would be quadrantal. Another one that's quadrantal would be a 180-degree angle, because that's right on the x-axis. And another one would be a 270-degree angle, because that angle would also be right on an axis. And then, of course, 360 degrees, or any rotation, that's 360 degrees more than one of these. So all these angles that fall right on the axis. To evaluate the trig functions of these, we're not going to use reference angles. We're going to use the unit circle and our definitions of sine, cosine, and tangent. And I'll show you what. It's not hard. It's just a totally different process. But once you see it done, you'll realize it's not too tricky. So I'm going to rewrite our definitions. Sine theta is y over r, cosine theta is x over r, tangent theta is y over x. You get these definitions in your head, you're going to be in good shape. So unit circle says that the radius of this circle is 1. We use 1 because it's just the easiest number. I could make the radius of this circle be anything. Eventually, when I do my sine, the ratio of the fraction is going to reduce to have 1 as the radius anyway. So since we're going to reduce down to 1, we might as well just start by using 1. So the radius of my circle is 1, which means the coordinate of this point right here on the axis has an x-coordinate of 1 and a y-coordinate of 0. Right? That's the point 1, 0. The point here is 0, 1. The point here is negative 1, 0. If you're just thinking in terms of like coordinate points, right? The x, comma, y. For this one, it's 0, negative 1. Right? So now we have an x, y labeled for each of the quadrantal angles. And I need an x and a y in order to evaluate, right, the sine, cosine, tangent, and we of course know that the radius of this circle is always 1. So now I have values that I can use for x, for y, and for the radius on each of the quadrantal angles. So if I ask you to do the sine of pi over 2, for example, pi over 2 is a 90-degree angle, right? It's 180 divided by 2. So if I go to my 90-degree angle, that would be right here. I know that sine is y divided by r. So I just figure out what's the y value right there at 90 degrees. The y value is 1. And the radius of a unit circle is always 1. And so the sine of 90 ends up being 1. Really simple, right? Let's do the sine of pi. So pi is a 180-degree angle. So the sine of pi would mean that I'm going to go fully 180 degrees to here and see what's the y value there, 0, divided by the radius of the unit circle, which is always 1, and that's just 0. So the sine of 180 degrees is 0. Of course, if you continue the pattern here, you'll notice that the sine of 270 degrees is going to be negative 1 over 1, which is just negative 1. And then the sine of 360 would be 0 again, because you're back to having y value 0. So pretty much the answers to these are just going to be 0 or 1 or negative 1. And then in a tangent, you may even have something undefined. Let's try to find an example of where it might be undefined. Tangent is a y divided by an x. So maybe I'll do the tangent of 3 pi over 2. 3 pi over 2, erase some of these markings over here, it's getting a little confusing. 3 pi over 2, 3 times 180 divided by 2 gives us 270 degrees. So a 270 degree angle brings us all the way around to here. So I'm looking at this point, 0, negative 1, and I have to do for a tangent a y divided by an x. So I'm looking at the y value of negative 1 divided by the x value of 0. And anytime I have 0 on the denominator of the fraction, which is only going to happen in a tangent case, then we're going to say that the answer is undefined. So when x is 0, then tangent is going to be undefined. In some other cases, you might get undefined if you're doing like a cosecant or a secant, right? If you had to flip upside down, this sine answer that we got. We had to flip that upside down because we're doing cosecant. Well, then that might be undefined also. So anytime you're going to end up with 0 in your denominator, the trig function is actually undefined there. So that would be your final answer. All right, we'll just do a final practice here. Evaluate each trig function. I think these are going to be not quadrantal angles. This is just how we should practice lumping it all together. Review what we just learned. Negative 240 degrees means that we're going to be leaving, heading south, going around the circle 180, past there to negative 240 degrees. The triangle that I want to use is this one, straight to the x-axis. 180 to 240 is 60 degrees. Labeling this with the root 3, it's positive because we're above the axis. Labeling this with the 1, it's negative because we're across on the left side. And the hypotenuse is 2, so now I can do my tangent, which is going to be y value over the x value, which is root 3 over negative 1, or negative root 3. So you should draw the triangle, draw the coordinate plane, do a little sketch like that. Guaranteed to get it right as long as you can draw that triangle correctly. All right, cosecant is 17 pi over 6. 17 pi over 6 is a big angle. 18 pi over 6 would be 3 pi. That would mean a rotation and a half around this thing. So we're just a little bit short of a rotation and a half. What I mean by that is going all the way around and halfway around again, but we're not quite reaching it because it's only 17 pi over 6, not 18 pi over 6. Let's erase a little bit of that. 17 pi over 6 puts us about here, right? We haven't quite gone around a circle and a half, which means there was only an additional pi over 6 left to go if we wanted to get to the x-axis. And pi over 6 is 30 degrees. So I'm going to label this triangle across from the 30. I have a 1. It's positive because we're above the axis. The x value would be across from here. It's going to be negative this time because we're on the left. And the hypotenuse of 30, 60, 90 is always 2. Cosecant means do the reciprocal of sine. So sine would be opposite over hypotenuse, which here would be 1 over 2. And the reciprocal of 1 over 2 is 2 over 1. So there's the answer. All right, and that's what you'll be asked to do on the back of your homework. That is all.